Hi, in this video I'm going to show you how you can import FPX files into Unity and start working on them as you like. For this project I'm going to use a robot and we will import the FPX file of a robot into Unity and then we will make it work. Like we will identify its joints, we will add joints to that robot, and then in the end when we'll play the scene the robot will work. It will perform the functions that we will make it to do. So in this start it's just an empty scene. I've just created a simple project in Unity 2019.4.1 and it contains a sample scene that is by default there, and let's import the FBX files. For importing the FBX files it's a pretty simple step. You don't need to do anything. Just select the folder which contains the FBX files. So here is my folder. Select it, drag it and drop it into Unity. Now the Unity will process the files. It will check if the files are okay, they don't contain any kind of error, the FBX files are not corrupted, and it will take some time. It will process the files, then it will show it in the SS folder. So as you can see, it's almost complete. Done. So this is the folder that I just imported and it contains all the files that we need to work on. So first of all, let's drag and drop the environment for the robot. This is an FBX file. This is, here it shows the model, and just select it, drag it and drop it into the scene window. Here you can see the model imported. So now it's in the scene window. It's a little bit dark. It's not in a proper coloring, so for that just go to lighting scene, and if your auto generate is off, just check it. It will take little second and now you can see it clearly. So this is the scene, or you can see this is the environment in which the robot will move. It will pick up the discs and it will throw, but that's not part of the video. The main part is adding joints, identifying and adding joints on the robot so it will perform the functions. So in the same way, just select the robot, drag it and drop it in the scene window. So let's reposition it properly. Let's bring it into the environment like this. So this is the robot. Initially it's not in the right rotation, so put it, so to put it in the right rotation, what we need to do is just select the robot and give a -90 rotation on its x-axis, and now you can see it's in the right rotation, it's in the right direction as well, facing the right direction. And now let's put it on the ground a little bit. Okay, cool. So this is our robot. So currently as you can see that this robot is connected to this one from where we dragged it. So if we will make any kind of changes, if we will make any kind of changes in this robot, it will be applied to this one. We don't want that. What we want is if we make any kind of changes in this robot, it should not affect the main one. So later on, if we need to use the main one, it will not be affected. So to separate this one from its parent, just right click on it and unpack prefab completely. Click on unpack prefab completely. Now this robot has no connection with this one. So let's start working on it. For simplicity, I will name it robot. Now, how this robot works. First of all, before adding joints on this robot, we need to identify how this robot works. What are its functions? Which part of these robots will move and how they will move. For example, these four are the wheels. Obviously, they will be used to drive the robot forward, backward. So these are the wheels, and these five rings that you can see, uh, these these will be used to pick the sliders, rings. These rings, these will be used to grab these rings and throw it in the direction, and these two wheels will be used to throw the ring. These five wheels will be used to drag them in, and these two rings will be used to throw them out. So before adding joints and before starting working on this robot, let's rename the parts so that we can find them easily. For example, this one is the wheel, this one is wheel, and we are going to name it back right wheel. Now this wheel is made up of many game objects. As you can see, this wheel contains multiple game objects. Multiple game objects are attached together to form this one complete wheel. So what we are going to do, we are going to rotate this wheel, but we are not going to rotate all the parts separately. That's not how it works. We need to select the parent. So before advancing, there is one thing you should know, and that is parent and child in Unity. As you can see, this back right wheel, which I just renamed, this is the parent, and all the game objects inside this parent are its child. So what is the difference between a parent and a child? If you move the parent, the child will move with them. All the childs will move with the parent. If you rotate the parent, all of the childs will rotate with the parent. But that's not with the case of a child. A child will behave in such a way that it will not affect the parent. For example, if I select this child, if I will move the child, it will not affect the position of the parent. Same, if I rotate the child, it will not affect the rotation of the parent. But if I select the parent again, that is the back right wheel, and if I move the parent, it will affect the position of the child. So this is the difference between a parent and a child in Unity, and this is really important to know, because later on when we will add joints to this robot, then this parent and child relation will be an important aspect to note, because we are going to add joints on the parent, not the child. Otherwise, it will not behave correctly. So, this was a little introduction about the parent and the child. Now, as we rename this tile, let's rename all of the other parts. So, when we start working on it, it will be easy for us uh, to specify or to check which part we are selecting, because currently you can see that we cannot identify the back right wheel, which one is the, we cannot identify using these names which one is the uh, front left wheel, which one is the back left wheel. So this is the front right wheel, and this one is the back left wheel, and this one is the front left wheel. So now it will be easy for us to select which wheel we want to work on. Yes, perfect. So first of all, let's start working with the wheels. We are going to add joints to the wheels and we are going to rotate them in forward direction. It will just look like the motor is running. So first of all, let's work on the front left wheel. Now, one other important thing that before adding joints you should know is where the pivot of the object lies, because when this when this wheel, front left wheel, or you can say when this parent will rotate, it will rotate on its pivot. So the pivot should be in the center of the parent for a perfect rotation, otherwise it will rotate and its position will also change. For example, as currently you can see that this gizmo, which you can see, this represents the pivot. When you will select it, select the parent, it will show its pivot. This is the pivot, and when you will rotate it, it will rotate like this. Why? Because it's rotating around its pivot, and it will always rotate around its pivot when we will add the joint. So this is not what we want. What we want is it should rotate exactly inside the center, like this. What I did, I just changed its pivot from pivot to center, but just changing it will not work, because when we'll add a joint, it will not check its center, it will check its pivot. So how can we do that? How can we rotate it around its perfect pivot? For that purpose, what we want is, we don't want to rotate the wheel. What we will rotate is, we will rotate this, uh, you can say that it's a rim. Just think of it as a rim. We will rotate this because it's perfectly on its position, it's not going up and down, and its pivot is on the right point. So we are going to rotate this one, and what are going to do is, as I described before, the parent and child relation, we are going to make this wheel the child of this rim. So when this rim rotates, the child will also rotate. And why are we doing this? Because the wheel's pivot is not on the right point and the rim's pivot is on the right point. So we are going to use this rim to rotate this wheel. So as you can see, this is the rim. We can say that we can rename it to front left rim. And how can we make this wheel the child of this rim? As I described before, it's simple. Just select the wheel and drag and drop it into the rim. Oops, sorry, let me just reposition it before. First, let's reposition it. Now we select the rim, we name it to front left rim, and then we are going to drag and drop this wheel into the rim. Now this wheel is the child of this rim. Now as you can see, before, this wheel's pivot is here, and if you move it, it will go up and down, which we don't want it. So now we are not going to rotate the wheel. What we are going to do is we are going to rotate the rim. Now if I rotate the rim, the wheel rotates perfectly. It's not going up and down because the child is rotating on the basis of its parent, and the pivot of the parent is exactly at the right position, so it's not behaving oddly. This is how you will work in Unity to identify how the things are going to work. You need to identify the right pivots, the right parent, and the right child. And once you do it, then the thing will work properly. So now it's not going to rotate on its own. What we need to do is we need to add a joint on this rim so that when we play the scene, the joint starts working and the wheel will start rotating. So before advancing, there are multiple joints in Unity. There are configurable joint, there is a spring joint, there is a fixed joint, and there is a hinge joint. So what kind of joint is better, or what kind of joint should be used to rotate the machinery? So uh, the amount of knowledge I have in joints is the best joint that you can use to work on the machinery is the hinge joint. This is commonly used while when you are working with physics and when you are working with machine parts or robots. So commonly the hinge joints are used. So as well as you will add the hinge joint, it will add a rigid body. Automatically it will add a rigid body to the component, because if you want to add a joint, rigid body is compulsory. So we are not going to connect it to any kind of body. It will be independent and it will rotate on its own. Now what we want it to rotate on its own. We don't want to do it with animation because that's not the right thing to do. We want physics, we want uh, real life, we want it to work like a real life machine. So as you can see, there are multiple attributes of this hinge joint. So there is one attribute that is known as the motor. What it does, it gives the velocity and force to the component, and it will apply the functions on the component, and it will do what you want it to do. For example, first of all, we will check this option that we are going to use this motor, and initially I'm going to give it a velocity of 200 and a force of 200. This force means that this object will apply the force of 200 on the rigid body. This is what it does. Torque, or you can say it a torque. It gives a 200 force to the target velocity. Now, when you will play the scene and go back to the scene window, as you can see that it is not rotating in the way we want. It's rotating on the x-axis, and we want the rotation on the z-axis. And why is this happening? We want, you see this blue line, it's the z-axis, this red line is the red x-axis, and this green line is the y-axis. What we want the movement to be on the z-axis, not the x-axis. So how can we do that? It's pretty simple. Just come back to the hinge joint, and here you can see the axis, and it's currently saying that the rotation should be on x-axis, and we don't want that. We will make it to 0, and we will make the z-axis to 1. We want the rotation on z-axis. And now when you will play the scene, it will work properly. It is rotating on the z-axis, as but now what is happening is that we have just added a rigid body, and it's applying gravity on the wheel. So what we need to do is we need to restrict the rigid body from changing its position. It will not go up and down, it will not go sideways, it will, this rigid body or this rim will stay on its position and it will rotate on its position. So now when you play the scene, it works properly. See, great. The wheel is rotating on the right point. It's not going up and down. It's not behaving oddly. It's rotating perfectly on the z-axis. As you can see, it's using this velocity and it's rotating on the z-axis. So why I have pointed out so many things and why I have focused in detail is that this is the same process that you are going to repeat for the rest of the parts of this machine. So I wanted to go in detail on the first wheel so that you can know in detail and you can know better how joints and how parent-child relation in Unity works if you want to make a robot move or work or whatever you want to do with the robot. So this is how we made one of the wheel of the robot to move. We have added the joint and it's moving. So the same process is going to be repeated for the rest of the wheels. I was checking this robot before and what I noticed is all of the pivots of all of the wheels are not at the right position. So we are going to repeat the same steps for the rest of the wheels. We are going to select the rims. We are going to make these wheels child of the rims and then we are going to add joints to the rims. Oops, just wait a second. So let's repeat the same steps for the rest of the wheels and in that way all of our 4 wheels will be ready and then we'll move to the next part, that is these 5 rings. So let's point out the rim of this wheel. We need to find the rim of this wheel so that we can make it parent and just click it and this is the rim of this wheel and we will name it back left rim. This was the front left rim, this is the back left rim and it's going to be parent of back left wheel, back left rim. So now when we rotate this rim on the z-axis, it will perfectly rotate the back wheel. So as we have made this wheel the child of this rim, what we are going to do, we are going to repeat the same steps again. Just add the hinge joint to this rim, check use motor, give it velocity and force. You can give it as much as you want. The higher the value, the faster this wheel will rotate, and we want to rotate it on the z-axis, not on the x-axis. Now again when we'll play this scene, the rim will still go up and down, and that is because, as I said before, we have added a rigid body on the wheel and now currently the gravity is being applied on the wheel. The joint is trying to fix it on its position but the gravity is trying to bring it down. So how can we fix it? Just in the rigid body section, go to the constraints and freeze the positions, and in that way the wheel will rotate perfectly on its pivot. Like this. So same steps for the right wheels. Okay, first of all select the wheel, then we are going to select the rim of the wheel. Sorry for odd behaviors that my Unity is doing. I'm currently working on a laptop and it's pretty slow. Okay, here is the rim. Just rim it to back right rim. So select the back right wheel. Here it is, back right wheel. Drag and drop it in back right rim. Perfect. Add hinge joint, freeze position so it doesn't go up and down, and check the use motor, give it force and velocity. Now there is going to be axis, we want the rotation on the z-axis. Now there is going to be a slight odd behavior, and what is that behavior is, the behavior is that when you'll see the wheel, it will not rotate in the direction that other wheels are rotating. Why is that? That is because the direction of both of these wheels are not the same. This wheel is not in the same direction as this wheel was. So whoever built this model, what he did, that he selected this wheel, he made a duplicate of this wheel, he flipped it on the y-axis. As you can see, it's flipped on -90. He flipped it on the y-axis and then he added this wheel on this side. So how can you make the rotation in the same direction as these rotations are? So it's pretty simple. This is going to be the opposite, this rotation is going to be the opposite of this one. So wait a second. So we are going to select this wheel, the rim that we added joint, and what you need to do is just give the z-axis -1 direction, so it will rotate it in the opposite direction. Now when you play the scene, and when you'll see in the scene, it's moving in the same direction as these wheels are moving. So we are going to do the same thing on the last one, on the last wheel. So first of all, check the rim on which we are going to rotate the wheel. This is the rim, front right rim. Okay, select the wheel and drag and drop it inside the front right rim. Now it's a child. Add the components, hinge joint component. In the rigid body section, freeze the position of the rim so that the gravity doesn't affect it, and give it a rotation of -1 on the z-axis, and for rotating it we are going to add velocity and force. Perfect. Now the four wheels of these motors are in working position. We just saw how you can identify the parts where the joints should be applied, and how you can add force or velocity to rotate that joint. As you can see, four of the wheels of this robot are working perfectly. Now there are two more steps to do on this robot, and that is we are going to rotate these flywheels as well as these five wheels which are going to suck the ring in, and these two wheels will throw the ring out. So let's finish that too. Now let's first work on these five wheels. There is one important thing you should know before working on it. Now, as you know that all of these five wheels will work exactly in the same way. They are not going to rotate differently. Each one of them will not have a different rotating speed. They will all rotate at the same speed and they will all work in the same way. Currently, these five wheels are separate. They have no connection with each other. But what we want is to have a single parent of all of them. We will similarly in the same way what we did with the wheels, we are going to add the joint on that parent and that parent will rotate all of these wheels simultaneously all together. They will rotate all together. So before adding the parent, what we need is we need to find where the parent should be added. The parent should be exactly in the center here, in the center of this wheel. That is the best position for it. If the parent is inside in the center of this wheel, then it will be the best pivot point for rotating the rest of the wheels. Now, first of all, I have selected this rod on which these wheels are connected and its name is axle. Just let's rename it to simplify it and we'll rename it to back rod. Cool, rename it to back rod. Currently the pivot of this back rod is not on the right position. As you can see it's going up and down. So we don't need to rotate this rod. What we will do is we will add an empty game object inside this rod. We will reposition it and we will reposition it in such a way that it will be exactly between the center of the rod. For positioning it perfectly, I will go into the orthogonic view. How you can do that is, as you can see, here is a sphere. Just click on the sphere and select the direction from which you want to see it, and it will go in that direction. Now let's select our game object, drag it, and try to put it exactly in the center so that while it's rotating it will not affect its position. Let's see it on the from the top side. Let's bring it exactly in the center. Okay, perfect. Now to check whether it's working perfectly or not, what we need to do is we will select and drag these five wheels and we will make them a child of this game object. Simple. Now if we rotate the parent on the z-axis, the childs are rotating, but as you can see they are rotating slightly up and down. Slightly, they are changing their position slightly. Why is that? Simple, because their pivot is not exactly in the center. So what we need to do is we will just reposition it a little bit, and I think the problem is, let's just reposition it a little bit forward. Now select and drag, and when you rotate it, they are, no, not the wheels, you are going to rotate the parent. So they are, as you can see, they are rotating, but still they are rotating a little bit up and down, but that's because the pivot is not exactly on the right position. But you get the idea how you can add a perfect pivot or add a right pivot of your own if the pivot of the robot is not at the right position. I've just showed you how you can add your own pivot. So this is how you can do it. Just do a little tweaking with it and you'll get the right position, but this gives the idea. Okay, but currently you can see that we cannot see the rotation of the wheels because the material, or you can say the color, is green and it doesn't show you clearly that whether they are moving or not. So for sake of simplicity, or for checking whether they are moving or not, I am going to add a little bit of texture on this material. Okay, let's leave the material for now. You can see that they are going up and down a little bit when they're moving, so we'll see that it will work. Okay, now to add joint, just do the same step, add component, hinge joint. We will freeze its position so that it doesn't go up and down, and we want the rotation on the z-axis, and just give it a velocity and force. Now when you will play the Unity scene, go to the scene window and you can see that parent is moving, or you can say the back wheels are moving. Perfect. This is how you can add a pivot of your own for perfect rotation if the pivot of the robot is not at the right position. You can set the pivots correctly while building the robot. If they are not set correctly, this is how you can make your own pivot. So the last step is the front two wheels, which we are going to work on. We are going to rotate them as well. But before that, let's point out, let's select where these wheels are. So this is the flywheel one, and as you can see that this flywheel have a motor which will be used to rotate it, and this is the motor. This motor will rotate on its pivot, and as you can see that its pivot is perfect. We don't need to add a new pivot as it is behaving perfectly. So we will rotate this motor on its pivot and the flywheel will rotate on its own, but it will not happen right now because the flywheel is separate and this motor is separate. So what we will do, as I have taught you before, we will make this flywheel the child of this motor. Now when we will rotate this motor, the flywheel will also rotate. You cannot see it clearly as it have green color, it's not prominent. I'll try to show it clearly once we add the joints. Let's add joint on the motor, same way, hinge joint. Let's freeze its positions. We are going to rotate it in the z-axis, and let's give it rotation. Now if you play the scene, so this is rotating like this. So let's work on the last part, which is the second flywheel, and on the bottom side it have the motor as well. This motor, this is the second wheel and this is the motor. Similarly, we will make this flywheel the child of this motor. We will add hinge joint on the motor. Just fix its positions, just give it rotation and velocity. Now there is one point that you need to remember, the same point with the wheels. Now the rotation of this wheel and this wheel are in the same direction. They are both rotating in that same direction, but we don't want that. What we want is they will both rotate in the opposite direction, so that the ring that is to be thrown will be thrown in the forward direction perfectly. And if they will rotate in the same direction, that will not happen. So we need to uh, rotate its direction. So we need to make its direction in the opposite side. So how we can do that? As we did for the wheel, just on the z-axis give it a negative rotation of -1, and in this way it will rotate in the opposite direction. See, now it's rotating in this direction, it's rotating in this direction, and this one is rotating in this direction. I think they're still rotating in the same direction. I need to give it rotation of 1 again. Perfect. Now it's rotating in this direction and this one is rotating in this direction, and in this way they will throw the ring perfectly. Or you get the idea how the rotation works. You can set the values of your own and you can make it work like whatever, however you want. So I hope you get the idea how the joints work in Unity, how you can make a robot to do different kind of functions in Unity using the joints. So as you can see that we added joints on the wheels, on the back side of these 5 wheels and on these 2 wheels. And the one important thing that you noticed is how you can make your own pivot if the pivot of the robot is not at the right position. So this is how you make a robot work in Unity.